In this lecture, we are going to discuss linear search. It is one of the key searching techniques in design and analysis of algorithms. Search is one of the basic operations in data structures. What do we mean by search? It is to find an element in the given input list is called search. Now we'll discuss linear search in detail. Linear search is a sequential search where search will happen in a sequential manner. So the search will happen in sequential manner, one after other. So this is how the search will happen. So the input for linear search can be sorted or unsorted. Any kind of input will be taken. And when it comes to linear search, it is to find an element or to search for an element in the given input list. There are two states in linear search. One is successful and the other one is unsuccessful. When the element that we are looking for is found, that is successful. If the element is not present in the given list, then it is called unsuccessful. Time complexity is order of n. We'll discuss it later. Now let us see with an example. So this is the given input 40, 21, 3, 86. The number of elements, it is 4. And the data to be searched is 3. This is the element that I'm looking for. Now we'll see how the search works. So 40, 21, 3, 86. So let me name with indices a of 0, a of 1, a of 2 and a of 3. Okay, what will happen here? First it will check at the 0th index whether a of 0 equals to 3. No. Then what will happen? It will move on to next index. That is called linear search. The search will happen sequentially. The next index, whether a of 1 is equal to 3. No. Then it will move to the next position, whether a of 2 equals to 3. Yes, the search is successful here. So this is how the linear search works. It will check one by one in a sequential manner. Every next element will be checked. The checking will happen until the element is found or the list gets exhausted. So let us discuss the generic pseudocode of this linear search. So this is the pseudocode of this linear search. So it will happen from 0. Okay, for I equals to 0, I less than n, I plus plus. So this is the basic part in this. The key operation here is this one. Okay, if a of I equals to data, then the element is found, you can quit. So this is the operation. This is a key operation in this pseudocode. What operation is this? This is a comparison operation. Okay, first it will check whether a of 0 equals to data. No, 40 is not equal to 3, right? Then it will move on to a of 1. Okay, in the next iteration, it will move on to a of 1 equals to data. No, false. Then again it will move on to a of 2. Whether a of 2 equals to data, yes, the element is found. So it will come out of the for loop. Okay. Then the one more thing is, if I equals to n, then we can conclude that element is not found. So what do we mean by I equals to n? So n is 4. In our example, n is 4. So it will go up to n equals to 3, right? So this for loop will go up to n equals to 3. Then at the last condition, it will check for I equals to n. If this condition is met, then we can conclude that element is not found. Coming to time complexity, for finding time complexity, we have to consider the key operation in our pseudocode. Here, comparison is the key operation as we discussed over here. There are 3 cases. So best case, worst case and average case. So let us discuss best case first. How many number of comparisons will happen in best case? What do you mean by best case? The element that we are looking for is present at the very first moment. So if my element is present at a of 0 itself, how many comparisons I made? Just one comparison. So that time, the time complexity is order of 1. When it comes to worst case, the element that I'm looking for is present at the last position, okay, at is n minus 1 position, or if the element that I'm looking for is not present, that time the number of comparisons could be n, right? At most I'll make n comparisons, okay, or n minus 1. So that time the worst case could be order of n. Average case, at least I would make n by 2 comparisons. So that we can say it as what? Order of n comparisons. So this is how the linear search works, and these are time complexities of linear search. Thanks for watching this video.